Hello and welcome back. Today I have something that looks a lot like what I did already before, and it's an LCD function generator. This time it is not the ADF 4351, but this time it is the MAX 2870. And this one is a little bit more expensive. I think the other one was around 35, and this one is around $50. And but this one goes from 23.5 up to 6,000 megahertz. So the range is a lot bigger because the other one was 35 to 4.4 gigahertz. And also the output level is a little bit higher. The other one was 0 dB, and then you could go lower, like a -3, -6, -9. And this one can go, let me get it correct, up to 5 dBm, and the lowest setting is -4. So there is a lot more output on this one. Also, this TCXO, the internal oscillator, is specified with 0.5 ppm, and the other one was unspecified. So I'm not sure if this one is really better or it was just not specified with the other one. Both you can change to have an external reference. I did already with my ADF, and maybe we can do the same with this one, but that's not going to be today. Yeah, I will keep a little list of what is the difference between both of them. I will zoom in on that later. But if we look at the board, they look completely similar, and I will zoom in on that. So here we have both of them. One is the ADF and the other is the MAX. And yeah, the PCBs look exactly the same to me. And yeah, only they use the different screws. Even the switches positions on the same. I did write it down on the back because I really didn't know which one was which. And so here we have it, both with the frequency ranges as well. Yeah, let's just remove the cover. Let's see. Okay, now I have a first look, except for my modification for the external reference. They really look the same. Only one should have a MAX chip, and the other should have the ADF. So I think we should get a microscope because I really don't see it. So I've been looking at both boards, and I don't see any difference other than the chip itself. So it's or the ADF or it's the MAX chip. So they also seem to be pin compatible because everything looks exactly the same. And why the output level of the MAX is a little bit higher, it's just because it's higher, because it comes directly out of the chip. There is no op amp in between. It's just directly out of the MAX chip. So that explains also because I thought maybe they're using a different op amp. But no, if we have a look here, we just have here a serial apron. If we have a look at the board, and I can just pick any because yeah, they are exactly the same. Voltage regulator. Here we have the Atmel 802, which I think is with the 24 CO2. It's a serial EEPROM. This HDM340E935. I have not able to find it, but it goes here to the USB, so it's probably the serial interface. Both boards runs on this ARM chip, the STM, and that is a Cortex M3 running on 72 megahertz with a clock of 8. Well, you've seen that also in the other board. And if we look here, we have the MAX, and as you can see, the soldering has been done later, and it doesn't necessarily look very nice. Sorry for the shaky. Here, now you can read better. And it's soldered later, but the board is the same. So this 20 euros in difference probably is the chip then only, because the rest looks exactly the same. And even the software that it runs on is also the same. And here you can see it's the ADF. And yeah, I hope I can put them in one screen. Maybe if I make two pictures that you can see that they are pin compatible. And yeah, maybe one is turned a little bit because here the letters are upside down and the pin 1 is in the right bottom. And where is my pin 1 here? Yeah, I don't see marking. Maybe it's the plus. I try to make two pictures. Well, I didn't see too much difference on the boards, and here we are looking at the TCXO, and it just says 25.000, and then it's 1 to 1, 2.33, I think it says. And then I cannot remember, so I will look for an old pictures of the ADF board because I put there already the switch, and maybe it just is exactly the same. Oh, here we can see. Yeah, the switch I need to take out, but it looks exactly the same. So yeah, then the difference should be really in the both of the chips. So well, I'm still a little bit confused why the Max LCD board cost around $55 and the ADF is around 35 because the whole board is exactly the same as I've seen. Even the TCXO seems exactly the same. So it's only the chip that maybe does the pricing. And if I look at the ADF, that one is available between $10 and $13, the chip only. And if I look at the Max, it is between 7 and 11. So it's cheaper than the ADF. So why is this board more expensive than the other one? Well, his frequency range is a lot wider because yeah, it starts as 23.5 and it goes all the way up to 6,000. While the other one starts at 35 and goes only to 4.4 gigahertz. Both is crazy high, but that is nice. So it must be demand. The people just like the ADF chip more, and they sell less. Well, especially with the higher price, they just sell that board less. What I do like to test is if indeed the output power is a lot higher. The higher frequency, I can only test up to 4.44 gigahertz. So the higher frequencies, I can only do on the frequency counter to see that it actually does do the higher frequencies. I will have a look on the spectrum analyzer as I also did with the ADF chip. And we saw when the point frequency, it was very clean, but when you did the sweep frequency, then you saw a lot of harmonics coming. And I wonder if it's the same with this board or not. Okay, if we look at the software, that is exactly the same now. You have here your point frequency. You can do a sweep between two frequencies. You can change the steps. There is the setting menu, and this one does exactly that. Here you can pick two chips, the 7.1 or the 70. And here you can also pick which one. But so that's it. And I have the question before that people said, yeah, here in the setting menu, you can set there if it's a sine or a square. And I did test that later, and well, in the lower frequencies, it starts to do a sort of a square, and we can check that on the oscilloscope. And in the higher frequency, it automatically becomes a square. And this one said square slash sine. And the other one just said square all the time, and you cannot change it. But I found out that in this firmware seems newer. The display is also darker. If we put here a higher frequency, and the turning point is around this 125 megahertz for both, that square starts to look so bad that it almost becomes a sine. A little fresher, what happened with the ADF chip. If we do a point, it is fairly clean, as we can see. It is just hitting here half of the box, and when I do a sweep, I sweep now between 990 and 10,010 with steps of 1K. And as you can see, we get a lot of noise here. And I wonder if the same noise happens with the max chip. Okay, max chip here. First we do a point. That looks very clean. This one is a little bit higher. It's just above this line, so it does output a little bit more. Now let's do a sweep, also between 990 and 110 with steps of 1K. Sweep. Here it goes. We see that the sweep is a lot slower. So, and we have the same steps. So the max chip does a slower sweep, but it looks a lot less noisy. There are indeed a few spikes still, but not as much as we saw with the ADF. So maybe if I change the steps, so let me put a 10K step instead of 1, and then maybe it is about the same speed. Yeah, I think this is the same sweep speed. I'm doing larger steps now, 10K, but yeah, it does look a lot cleaner. So the pricing must then be in the quality of the chip, but we already saw that the chip was cheaper, so I'm still confused. Okay, now about this square or sine wave, what comes out of this, which you cannot change in the display. Let me zoom in on the oscilloscope a little bit. I put now 35 megahertz because both of the generators can do that. And I will do a point. And as you can see, I did terminate it, of course. As you can see, it is sort of a square wave. At least it has nice rising edges, which you use. So that is a square, but when we go higher, and I think the turning point, the tipping point was around 100, that it really starts to be a sine. So I will put now 100. And I put a point. As you can see, it already starts to be less of a square, and it becomes a sine. And well, my oscilloscope goes up to 200, so stop. Let me do 150. And I put a point, and now it starts to be a very nice sine wave. So that is what happens. It is a square up to, yeah, 100. I can try to go higher, but the sine is a sine now. So it's not going to be a square in a higher frequency. 200. Yeah, the oscilloscope does indeed still do 200 megahertz. Maybe it can even go higher. Let me do 250, just for fun. But now I'm testing more the oscilloscope than my generator. Yeah, it still shows. Cool. It even goes up to 300, but as you can see, the level drops a little bit. So yeah, probably the Chinese it will say it goes up to 400, but Cyclone just says we want to be safe, we call it 200, but it's cool. Okay, but I was not testing that. Let's go to the max and see where that turning point is. Okay, this is the max chip. Yeah, the wave looks exactly the same. Also not necessarily very clean, but you have nice rising edges. So let's go to 100 megahertz. 100. point. And this one also, you see already it starts to be more and more sine wave at 100. So if I go again to 200, now I did 150 first, 150. And then you can see it starts to be already nice. And we can go to 200. Yes, and we see a wave. Well, you see now it's big, and if I go to, I will do the same, 300. It will indeed still show a lot smaller, but it works. Let's put them both on the frequency counter and see which one is more accurate. This one is connected to my external reference, so it's spot on. And it seems that the ADF is doing 999.994. And what does the MAX do? Oh, that's the external reference. It is doing worse. So I know already also for this this MAX board we need to make an external reference, and it's very easy, as you see in my other video about the ADF. Okay, for the output, yeah, there are 4 settings. You can see the slider, and this is 4, 3, 2, 1. So you have 4 settings. This is the highest level, and as I did with the ADF, I will do the same here, and the power should be higher. I think I did 50, 100, 200, 500, and 1000 megahertz on the Marconi, and then later I switch over to the PC spectrum analyzer to see how much power it will give on the higher frequencies. Okay, I'm now with the max on the lowest setting, and I remember in the other one that was minus 9 dB. I think that was 1.25 microwatts, and here it's around 190. And if we go to the setting to the second, instead of 250, we have here 380. So indeed, the max has a lot more output power. Go to the third setting point. Here instead of 0.5, we have here 780. And on the higher setting, that was 1 milliwatt in the other. And that is here. Look at that, 1.6. So it is indeed much more. I will check the other frequencies and later show you the table. Yeah, to measure the power above 1 gigahertz, I cannot use my Marconi, and I'm using here my little USB spectrum analyzer. This one goes up to 4.4 gigahertz. And well, I did 1 gigahertz with the Marconi, so I'm gonna do a reference now. I think I'm already sweeping. Yes, I am. Let me zoom in a little bit. Yeah, as you can see, it is just above, so it could be like 4 or 5 dB. And as you can see, it is just above. So now I will do 2. I'm checking now the lowest setting of the 4, and this one, if I should guess, it's like -2, and the other setting was 0, and the other was +2, and the maximum was 4.2. So it seems more or less to do what they say. And now I will check also the higher frequencies. Okay, now I'm scanning between 1.9 and 2.1 gigahertz. I will start to put a point. This is the lowest setting, and Yeah, this would be -5, I think. Then we try the other setting. Stop setting, second level point. This would be -2, I think. Third power level. Almost 0. -1, I would say. The highest setting point. Now this is closer to 0 than +4. Yeah, I tried now also on the 4 gigahertz, and then it's almost hitting the 1. I would say it's more like -2, -1, -2. So on the really high frequencies, it just drops, but it could be my cable, it could be this cheap USB spectrum analyzer. But at least we get an idea what the numbers do, and I will put it in a nice table for you. Now, and if you can see the software of the ADF and MAX is exactly the same. It even has the same bug that this 25 megahertz reference here is blocking everything. So I know it was COM5, so I say open COM, and then I have here my point frequency, and if I say point, it will complain. It says you need to enter a range, and this is and then it even gives an error. But if you put here just normal 25, it will accept it. So you can totally ignore that. And now it works. Data sent successfully, and the max is doing a point frequency, and now I stop. So that is exactly the same as with the ADF. So that was it. It was also a little bit of a comparison, but the bots are very similar. So if you're doubting which one to buy, it purely depends on, do you need more than 0 dB, and do you go below 35 megahertz or above the 4.4? And if you don't, and 0 dBm is enough for you, then you can just go for the ADF for around $35 instead of for the max. If you're really going to use the sweep option to have a start frequency, end frequency, and then step to do a sort of a scan, then you're maybe better off with the max, because the max, it scans a bit slower. You can do the same steps. At least I try a few settings. It scans a bit slower. But it is a lot cleaner, as you have seen on the spectrum analyzer. So that could be one of your choices. But I like to have both. I will still do an external reference connection. It's probably just the same, removing this 0 ohms resistor, and I will put the switch again so it's switchable. So if I don't have my external reference, I can still use it. So, but you will find it on my other videos later. Thank you for watching for now, and I hope to see you next time.